A very good morning, all of you. I'm welcoming you for Engineering Mechanics lectures online lecture series for module number 3. The topic name is Equilibrium of Force System, and the Friction. We'll discuss the different type of equilibrium supports, then what are the different type of beams, then different type of hinges. Okay, what are the different reactions can be occurred because of the support and various beams. Okay, so this is a basic in a scenario which we are going to be understand in this lecture. So basically there are different type of supports. We will discuss one by one. uh, the main concept of converting the problem into the forces and reactions, it's called as a free body diagram. Okay, that is the most important step to solve the any kind of problem with respect to mechanics. Okay, so for that there are different types of supports which we needed to find out what they actually reacting, how they are providing the opposite reactions. Okay, so let us say start with the smooth surface contact. Okay, in the smooth surface contact, uh, the basically a simple cylinder is placed over a horizontal surface. So there are two reactions. First, its own weight W, and the normal reactions which is occurred because of the friction in between the cylinder and surface, that we can say RA reaction, that is a single point reaction. In second problem, or you can say second sample, the ball or a sphere is placed in between a particular stack. Okay, where there are three phases of contact. So first phase of contact is over here. This is in a bottom contact, and third one is a angular contact. So there are three reactions which is occurring. First, RA, which is perpendicular to the first surface, R1. R2 is perpendicular with the second surface, that is number 2, and reaction N, that is normal reaction with respect to the horizontal surface. And fourth force will be occurred is its own self weight. Okay, so normally whenever you are converting the any kind of problem into the simple free body diagram, you have to consider the type of reaction. Okay, so if you have a simple smooth surface contact, then you have to refer these reactions. Next one, next a few samples where two cylinders are placed in one container. Okay, first container is having a surface contact at point 1, 2 and 4. Okay, fourth contact with the another particle. When we consider two particles, or you can say whole system with a free body diagram, okay, so we could not write any force in between two touching bodies. Okay, so only write down the reactions related to the total system. So first reaction R1 is here, second reaction R2 is here, then first sulfate of cylinder 1, sulfate of cylinder 2, and third normal reaction at point 3. Okay, so that when we consider two spheres are together with each other, or two cylinders together with each other, when we go with the separate one by one, when we consider these entities are separate, so first entity you can say this one, and second one is this one. So for first cylinder, or you can say sphere, there are four different forces acting over there. Out of that, one is a sulfate and three are the reactions. So reaction at point 1 with vertical surface, reaction at point 2 with a horizontal surface, and reaction at point 4, which is nothing but the surface to surface contact of first sphere to second sphere. Okay, now carefully look at the direction of reactions. Reaction is always occurred opposite, opposite in direction. So direction of R4 in case of first sphere is towards the center. Similarly for R4 reaction for small cylinder, or can say small sphere, is towards its center. Okay, so similarly uh, you can identify the point of contacts, and you can identify the reactions which is occurred during the free body diagram. You can identify that and you can mark it. Okay, another one, when we consider any link or ladder which is placed over the vertical and horizontal surface, so always there are two reactions, because we are considering it is in a smooth surface contact. Okay, so normal reaction over here at reaction at point B, and this is a horizontal reaction, that is a perpendicular reaction at point A, and at the center its own weight, that is W, which we have drawn in this figure. Okay, so I hope you have understood the first concept. Now second type is a roller support. Second type is a roller support. Whenever the frictionless surface, or you can say support occurring with the frictionless, we generally consider a roller type of support. Okay, it exert only one type of force. If the roller is rotating in a horizontal reaction, there is a exerting force which is perpendicular to the surface support, to the surface support. In a simple example, or you can say simple words, if the force is perpendicular, if the force is sorry, if the slider is rotating in a horizontal direction, there is only one reaction is occurred which is a perpendicular to the direction, that is a vertical reaction. Okay, so when you look the position of the roller, the reaction is a perpendicular, the reaction is a perpendicular. In similar way, the different type of ways to show the roller support and their reaction, and their reaction, because in this roller support the roller are free to move in the symbol one direction, so there is a support, friction will be occur wherever the rollers are getting in contact. So that's why the normal reaction is occurred in this direction. Okay, if you have a roller support in a particular angle theta, then your reaction is having angular theta with, now we look at here, it is having an angular theta with reaction, so perpendicular with the horizontal, so you can place the theta angle with respect to vertical and show the reaction. Okay, where these kind of roller supports are used, normally we are using this kind of roller support in a treadmill, where people are going for jogging. Another example is a belt conveyor, okay, where the small and big size of raw materials can be transferred from one place to another place. Okay, Normally they can use in the application like coal mines, then where the automated machineries are used uh, in that scenarios, the conveyor belts are used. Next one is a hinge support. Okay, in a simple, first of all, let understood the application. Hinge support, whenever you are opening and closing any door at the connecting point of view, there is a hinge which is given or which is attached with the wall. The door is attached with the wall with the help of hinge. Okay, so hinge is only having a rotational motion. There is no vertical or horizontal displacement. Okay, so it in a simple manner, there is a displacement is totally linear and horizontal displacement is sorry, vertical and horizontal displacement is a totally restricted. So the reaction offers at the hinge at support A, which is having a particular angle, which is having a particular angle. So any angular force we are converted into two components, that is a horizontal component and vertical component. Okay, so whenever you are considering any hinge support, there are one reaction which is angular with respect to horizontal or vertical, and we can convert this into two components, that is a horizontal component and vertical component. Another example, if you observe the cylinder block of any IC engine, there is a pin in cylinder which is slightly smaller than the hole which is used to be inserted, and whatever the force is acting over that cylinder, okay, that can be transferred with the help of this pin to the piston, from connecting rod to pin to piston. Okay, so there is only one normal reaction which is considered, that as a contact surface, which is shown. Okay, another examples, you have three different examples of, first one is about the door, second one is about the laptop, and third one is the suitcase. Okay, so these are the suitable examples which to understand the basic concept of hinge support. Okay, next one. Now the hinge support in different positions, let us say. So in a first position it is totally horizontal, so there are again the angles r theta is there, okay, which is converted into two forces, that is vertical component and horizontal component. So whenever you are using hinge reaction, always remember there are two forces, which is a horizontal component and vertical component. Okay, so different uh, ways to represent this hinge support is shown over in the this table. Okay, also supported reactions are also shown. You have to remember the different type of the way the hinge support is shown. Okay, because in this particular example, might student might be confused related to roller support and hinge support. Okay, for roller support, the rollers are getting added in the bottom. Okay, in this bottom area the roller is added. Okay, so it's look like this one. Okay, otherwise if it is not added, it means that this is nothing but a hinge support. Okay, so you must be understood about the hinge support, because normally in examples the hinge support is regularly used. Okay, uh, next type. Fixed support. Uh, when one end of a beam, or you can say a rod, which is fixed inside the any wall or any ground, that is called as a fixed support. Okay, because in this point it will not be allowed to move that particular end in any direction, neither vertical, neither horizontal, nor rotational. Okay, in hinge support there is a rotational displacement of, of an that pin, but in this case there is a no there is any kind of displacement or rotational movement will not be occurred. Okay, so that's why it is called as a fixed support, which restricted the different reactions. Okay, first reaction, the okay, for this one you can simply just a minute. Okay, for this you have a two different reactions. First one, this horizontal and vertical component which is occurred by the reaction at an angle theta, then it's not able to rotational, so that's why there is a moment is acting. Okay, so there are three forces. First, horizontal component, vertical component, because it is restricted in horizontal vertical direction. Also, the rotational movement is restricted, so there is a couple. There is a couple. Okay. So for fixed beam, or you can say fixed support, there are three types of reactions occurred. First, horizontal component and vertical component of angular reaction, and second one is moment of rotational motion. Okay, so you can see the fixed support in three different ways that can be shown in examples. First one, it is horizontally restricted and force is applied in a downward direction. In second example, it is placed in the ground, okay, at the bottom, and force is applied in a anti-clockwise direction. Okay, so you can see the reactions for second example. One horizontal force is applied opposite to the force applied, then vertical component is applied towards the upward. Then if you look at the movement, it is opposite. It is a opposite in direction. The force is applied in anti-clockwise direction and the movement is applied in a clockwise direction. So remember this thing, whichever whatever the force direction is there, the moment in a fixed support is applied in opposite direction. Clear? Okay, now last one, third one, the part is welded, the horizontal plate is welded with the vertical plate. So in that also three components we can see: vertical, horizontal, and moment. So whenever you found the fixed supported beam, or you can say fixed support to any beam or an example, there are three forces, there are three motions are to be restricted: horizontal, vertical, and rotational. So that's why these three components are getting applied. Next one is a freely sliding guide. Okay, uh, this kind of examples we can see in a piston connecting rod, or you can say you have a injectors uh, of a syringe, and that also you can find out this sliding support, freely sliding guide example. Okay, a slider which is freely moved inside the guider, inside the guiding surface. It could be a horizontal, vertical cylinder, could be a slot, it could be an what do you say, sliding over the cylinder or under the cylinder. For example, windows are there which is slide over the particular slot. Then rails are there which is start to slide over the track. Okay. Then piston and cylinder option is there which is freely slide over a particular distance. Okay, so these are the normal, we can consider a free slide kind, or you can say a one slider mechanism which is shown in a figure, vertical and horizontal. You can use that slider mechanism. Okay, if slider is moving having a movement in a horizontal, always always remember your reaction is a vertical, because the vertical motion is get restricted. Okay, reaction is normally occurred wherever, whichever the direction of motion is get restricted. Okay, now in about second example, in the second example, the slider is rotating in a vertical direction. Okay, so it means that the horizontal movement is getting restricted. So the reaction is occurred in a horizontal form. Okay, so look at here. I hope it is quite easy to understand. Next one is a gravitational attraction. Okay, so gravitational force is nothing but it's a sum of all the mass into gravitational force, that is a mg. Okay, for each mass, and which is acting at a particular distance, that is a centroid position. Okay, and that of, because of that, the whole mass of the body getting applied, that we are considering as a weight, that is we denoted as a w. So that gravitational attraction is nothing but it can be occurred with the object or body which having a mass. Okay, if the mass is negligible, there in this case we neglect the gravitational attraction. Next one is the spring force. The spring force is normally occurred with an example where the springs or the reaction like a springs we are using. Okay, for example, a support system. You have already done the first experiment, that in that we are using a fulcrum where the spring is attached in a opposite direction, we are applying the weight. Okay, so the whichever the weight is applied, equal and opposite spring force is applied over the that fulcrum, which need to be in equilibrium. Okay, so in that simple case, the spring force is nothing but the constant spring the constant spring constant and the deformation of the spring. When we consider the product of these the two parameters, we will get a spring force. It is a equal, it is might be tensile form, or it is might be in a compressive form. Okay, next one is a inextensible string, cable, belt rope, cord, or chain or wire. It is very obvious if in example we are using these different uh, materials to apply or to develop forces. Okay, if any cases we can use string, chain, belt to provide a reaction, or sorry, to provide a force, or to uh, belt, or you can say to restrict the motion. So when it is an inextensible, it means that it should not change its length. In that time, we can directly use the reaction as a tension. The reaction as a tension. For example, a cylinder is hanged vertically with the help of cord. with the help of cord. So first of all, the weight of cylinder is acting in downward direction, and there is a string which is in between in this point and in this point. Okay, so there is obvious the tension is occurred in between this string. So only we are considering the tension. Only we are considering the tension. This medium might be string, cable, rope, cord, chain, or wire. Okay, this medium will be any of them. We can convert this in a free body diagram like this. Okay, in a simple second example, the force is applied in an angular form. Sorry, the restriction is applied in angle of theta with the horizontal, and it moves in a horizontal direction. Okay, so with the angle of theta, the tension is applied in opposite direction. Clear? Next one is a rope and frictionless pulley arrangement. Now this is very important to understand because there are two concepts we need to be understood. First one, when is a frictionless pulley is there, obviously uh, there is no reaction, okay, in the medium. But when you consider this area, this is a hinge support. This is a hinge support. We can say because why it is a hinge support? There is a restriction in linear motion. It can be rotate in a angular rotary motion only. So we have a two strings is attached over here. First string is connected with the ground, and second is having a applied weight of 100 kg. So whatever the tension is created because of that 100 kg, which is equally distributed in both sides because it is applied with the tension. Okay, so T1, the value of T is 981, which is applied equally in both side, equal and opposite reaction uh, direction. Now next about by considering this hinge support, as we know that in a hinge support the angular reaction will be occurred, and which is converted into two components. That first one is a horizontal component and second one is a vertical component which is acting at the center. So accurately we have shown over here. Okay, now second example, if we want to convert this force in quite small angular direction. Okay, so one support is sorry, support. Now here the support is was vertical. Now here we are applying this support in an angular direction. So again there is no change in a tension value. Okay, whichever it can might be angle applied in angular direction, it might be a horizontal, vertical. So whichever in the direction, the tension value will be same in both side. Okay, in a both side. I hope the figures are itself explanatory to understand this concept. Okay, another third one we have shown, the one is attachment with the horizontal and the force is applied in a vertical direction. The value of tension will be same in both direction. Next one, if you want to transfer the tension of the rope on a frictionless pulley from circumference to the center of pulley. So why such kind of thing is required to do? As the frictionless pulley and tension in both sides are must be equal. Therefore, the free body diagram of pulley, the tension on both sides can be same, and which is applied at the center. So the reason behind that, we know that the forces can be transferred from one point to another point from a rigid body by moving new point with the parallel line of an action, with the parallel line of action, and adding the couple, those magnitude is equal to the movement of the force about the new transport point. Here it is in a center, so the both forces which are the tangential to the circle, they are perpendicular to the perpendicular distance which is equal to the radius of the pulley, so that these two forces having the same magnitude and that can be transferred to the center, which carries the couple value equal to tension into radius, that is momentum, opposite in sense, hence they can cancel with each other. Let us discuss with the diagram. So there are two forces offered, that is this T and this T. Okay, those both T's are equal in a sense or equal in a magnitude. Look at this. Okay, now we can transfer this circumferential force at the center. So the distance from center to circumference is r, that is the radius. So the value of moment, or say you can couple, is nothing but t into r, t into r. Now look at the direction. It is in upward direction, it is in downward direction. So couple is acting in anti-clockwise direction and this one is a clockwise direction. Okay, based on the directions, but having both c value, or we can say both couples having equal and opposite magnitude, direction will direction same magnitude and equal and opposite direction, so both are getting cancelled. Okay, so only we have a three reactions. First, tension due to weight, tension due to support, then there is a hinge support is provided over here, so there is a vertical component, this is vertical component and horizontal component. So total four forces are acting at the center of frictionless pulley. Next one, uh, the straight rod supported by the knife edge, we can say simply fulcrum. Okay, uh, a straight rod having a weight W which is against the horizontal smooth surface and placed at the knife edge on a vertical surface, which is shown in figure. Okay, so there are two reactions which is normally occurred. First one, because of smooth surface, there is a perpendicular reaction Ra. At knife edge point B, there is a perpendicular reaction which is occurred. Okay, that is Rb. Okay, next, third is its own weight, its own weight. Now if you have a smooth surface over here also, we have a horizontal reaction, but it is applied at a particular angle with respect to the horizontal theta. Okay, so if we have a reaction that should be perpendicular to the surface, now let us consider this one is a surface and this one is a perpendicular reaction. Okay, so which is shown over here. Okay, whenever you have a knife edge support which have a normal reaction which is perpendicular to the straight of rod, straight rod. Next one, rigid support by knife edge, rigid support, a rigid body supported by knife edge. Previously we have seen about the rod, now we are looking for the rigid bodies. So let us say a cylinder rolling over the horizontal surface and having a step, over that step it has to be climbed. Okay, so first thing which are keeping in mind that there are different basic forces acting over the surface, basic forces which is acting over the surface. First of all, this one is a cylinder, so there is sulfate is there. Then we are applying force with the angle theta with the horizontal, which is in kept in mind. So W is there, P is there. Now there are another thing which is getting added. So first, this one should be considered at point B, and now we are considering the knife edge. So for that knife edge we have to draw a tangential line. Okay, so this one is a tangential line, and perpendicular to that line the reaction get applied. Perpendicular to that line the reaction get applied. This is placed over here. Okay, so we will get these kind of forces. Similarly, the force is applied in first case, the force is applied at the center, and in the second case, the force is applied at the top of the uh, periphery of a cylinder. Okay, so only the value of location of the P is getting changed, and other reactions will be also modified. The angle is consequently made with for the reaction getting changed as the position of the force applied get modified. Okay, so when you consider first case, the force is applied at the center. Okay, in the first case the force is applied at the center. So because of that, the center is connected with this point, and whichever the angle it is made, okay, which is angle it is made with the horizontal, that is considered as a theta, and which is equally distributed over here also. Okay, now in second case the force is applied at point A, so it is connected with the P because the reaction is allocated towards this point, towards this point. So reaction angle will be considered this one, okay, which is shown over here. I hope you are able to understand the difference between these two uh, examples. The position of the P is very important to identify the angle and direction of the reaction because of knife edge. Now next one is beam. Beam is nothing but it is structural element designed to withstand a different type of loads. Okay. Normally, whenever we block making buildings, we are using different type of beams which having a different shapes, and they have a different ability to withstand the different loads. Okay, so in this condition, you can see this is a fixed beam, and the force is applied over the total span of this area. Okay, so there are different beam you can see in these figures with the different supports. Now simply support different types of beams we will discuss one by one. So first one is a simply supported beam. So name indicates the beams are supported by normally hinge one end, or you can say or by roller. Okay, in this example the simply beam is supported by left side, that is hinge support, and right side it is roller support, and there are three different forces is getting applied. So whenever we consider about the reactions because of the supports, as we know that the hinge support having a two forces, there is a one reaction which is angular reaction converted into two forces, that is a horizontal component and vertical component at point A. At point B, there is a roller support. So as the roller support is provided, we know that the if it is it having a motion in a horizontal direction, the vertical motion is get restricted, and because of the reaction is occurred in a vertical direction. So at point B, RB was applied from what upward direction. Now second example, a simply supported beam with the overhang. Okay, overhang, it means that a particular area of an beam which is end of an beam which is not supported by any kind of support. So it can be freely able to rotate. Okay, if you observe this, the both ends are connected by the support, and in this both ends are free in between the forces, in between the beams. Okay, this is a free, this one is a free, both ends are free, and in between the hinge support and the roller support is getting applied. Okay, so in this case you have a force which is in a downward direction, as we know that when we consider a movement of point A, the in left side the sign convention is totally opposite which we are considering in a right side. Okay, and the reactions which is occurred offered at point A is a horizontal reaction, vertical reaction. At point B, as a roller support, it's only vertical reaction, as the roller is rotate are able to move in a horizontal direction. Then next one is a cantilever beam. In cantilever beam, it is simply we can say one end is a fixed and other is free to rotate. Okay, so it is called as a cantilever beam. So cantilever beam, as we know that the fixed support is there. So in the fixed support, there are three types of uh, forces we can identify. Two components of one angular reaction, that is a horizontal component at point A, vertical component at point B, and there is a couple or you can say movement at point A having a distance this one. And next one, if you have a free point, there will be no reaction can be considered. Okay, at fixed point it might be welded, bolted, nailed, riveted, or concreted, any kind of method we can use for making the fixed support. Next one is a continuous beam. Now this one is a very important because we have a multiple supports and multiple forces over here, which is nothing but you can say if you consider point A to second hinge, it is one span. Second here to here, second and third. So beam is supported by the multiple number of supports and which is able to carry more load as compared to the single load. In a simple example, if the beam length is more, because of self weight it get bent and the ability to withstand with the forces get reduced. To increase this ability we can apply or increase the multiple supports so that the beam reaction or bending process will be get removed or you can say minimized. So that's why multiple supports are getting applied. Okay, so this is a kind of called as a continuous beam. The beam linked with the internal hinges. The beam linked with the internal hinges. So there is a one beam span from A to C which is given, and second one is a hinge separately with C to D. So there are two different beams which is hinged at a location of C. So whenever you are finding the free body diagram, there are two components or you can say two particles or two bodies. So we have to find out the free body diagram for each body. So for first body, that is A to C beam, first at 8 point A it is hinged, so horizontal and vertical reaction is there. F1 is shown properly. At point B, the roller support is there, so vertical RB is there. And at point C, it is again hinged. So there are horizontal and vertical component is there. Okay. Now equal and opposite. C to D. If your component is acting vertically, because this force is acting vertically over here. Okay. And your hinges at behind behind this force, or you can say after the support. So vertical here, the reaction is occurred over here, and horizontal surface because the force acting from this side and this side. Okay, so that's why in this first beam at the end, the vertical direction of vertical component is vertical upward, and horizontal upward towards the left. In C to D, the direction of vertical and horizontal component is directly opposite. It's shown in over here. Okay, which is towards the right horizontal, and for vertical towards the bottom. And at the end there is a roller reaction, a roller support is there, so only vertical reaction is getting added over here. So simply you can make the free body diagram when you have a beam linked with the hinge support, linked with the internal hinge, linked with the internal hinge. Now different type of loads, we need to understand different type of loads because there are various uh, type of loads are available, and we need to convert multiple loads in a single load. We can called as a reaction. Okay, and if you have to convert single load in a multiple two loads, that we can component call as a components. Okay, so first of all, the first type of load is a point load. Okay, the load acting on a particular point, or which is concentrated at a particular point, is called as a point load. In this case, F1 is concentrated at this point, so it is called as a point load. It is angular but concentrated over this point, so it is also called as a point load. I hope this kind of concept is very easy to understand. Now next one is a distributed load. Distributed load, uh, within this simple example, if we look at the dam, the water pressure is applied equally, or you can say it can be distributed in a particular direction. Or in a simple example, if you press your hand over the surface, the forces might be equally distributed or unequally distributed, but the force is distributed over the surface which is in a contact with the surface. Okay, whenever the area of your hand which is connected over the surface, okay, where you are pushing the force, the total forces get distributed over the surface, over the area of your hand. Okay, so that's why it is called the distributed load. Another example, if you put a book over the table, so area of book is provided equal force over the total area of that surface. Okay, so another is a hydraulic pressure which is applied over the dams, which is equally distributed, equal, or it is simply said distributed load. Okay, so the intensity of this load we can find out by the load which is applied per unit length, the load applied per unit length, and it having a unit newton per meter or kilonewton per meter. Okay, so if you have a distributed type of load, you have to convert this distributed type of load into single point load, and we will first understood the different type of distributed load, and then we will discuss the how we can convert distributed load in a single point load. So first type of distributed load is uniform distributed load. Uniform distributed load. So in this area, the intensity of load is distributed uniformly over the length. In a simple example, a truck having a particular loaded with an X material. So whatever the load is occurred in that particular container that is equally distributed among the total area, okay, which is denoted by W Newton per meter, okay, and uniform distributed load are denoted like this. This is shown like this, okay. The force which is acting from started from this point and ended from this point are equally having a equal height, having a equal height of that forces. Another example is the slab is applied over the beams. The slab thickness will be equal in both all the direction. So the whatever the force is applied, which is same and equally distributed among that area. So whenever you are converting the uniform distributed load into the single point load, you might be convert with the help of this equation. So that is W into L. W into L. You can write down L like this. Okay. So weight per unit multiplied by the length. At what span it is multiplied. That is the magnitude of that single point load and the location. Now location can be find out from point A, which is nothing but it can be applied at the center. So the length is L by 2. The length is L by 2. In few example, it is denoted like this. The uniform distributed load. Look at this. The all curves are equally in size. So it means that it is uniformly distributed load. Okay. And which is applied over the span of length L. So W into L is the magnitude of single point load and which is located from point A at the distance L by 2. At the distance L by 2. Okay. In simple, if you have a uniform distributed load, to find out the magnitude for single, you can refer this equation W into L. For example, if this is a 5 Newton per meter, which is applied over the 7 meter area, or you can say 2 meter area, ekdam to understand the simple manner, 2 meter area. So single point load value is 5 into 2 is a 10 is equal to 10 Newton meter, Newton per meter, Newton per meter is the magnitude of single force. Now we need to identify the location. To identify location, simple. There is equation L by 2 from point A because it is started from point A to B. Okay. So from point A, the length is L by 2. So the point is at 1 meter. We have a total length of beam is 2 meter. So this one is applied at 1 meter. Okay. I hope you have understood the conversion of uniform distributed load into single point load. Into single point load. Okay. If you have done any doubt, you can feel free to ask personally. Now next one. Now next is just a minute. Next one. This is an example for uniform distributed load which we have discussed previously just before, because in this area the total uniform magnitude is 5 kilonewton per meter and the span is 6 meter. Okay. Now the magnitude of this single point is 5 into 6, that is 30 kilonewton, and the distance is 6 by 2, that is 3 meter from point A. Okay. Now here also look at the both are same, both are uniformly distributed loads, but only the way to represent is different. Okay, you need to, don't worry about if any of these way they have mentioned the uniform distributed load. You don't need not to worry. You simply convert this into the single point force. Now you look at here, the magnitude of this force is a uniform distributed load is 3 kilonewton per meter, and the length is 4 meter. So total magnitude of single force is 4 into 3, that is 12 kilonewton. And about the distance from this point, it is L by 2. From this point it is L by 2, or from this point B also you can say L by 2. So 4 meter is there, half of that is 2 meter, so it is applied at a 2 meter. So in this way you can convert the uniform distributed load into single point at a distance. Uniform distributed load again. Second one, non-uniform distributed load. Okay, second one is a non-uniform, because in previous the total force area throughout from start to end will be equal, but in this case it is not equally distributed. It is called as non-uniform distributed load. Okay, point A it is 0, at point B it is maximum. The value of that force is again W. Now we have to convert this non-uniform distributed load into single point. Okay, first of all calculate the magnitude. To calculate the magnitude, the equation is 1 half into L into W. If it is a 5 Newton per meter, the and length is 2 meter, then what is the value of magnitude now? 1 half into 2 into 5. So that is 5 Newton. That is 5 Newton. Okay. Now what is the location from point A to point B? As we know that at point A it is having very 0, and at point B it is at a maximum level. So from point A it is 2/3 of L, and from point B it is 1/3 of L. The location is, you can find out from the load where is 0. From that point the load can be placed at 2/3 location, 2/3 length of the non-uniform distributed load. Okay, so here the 2 meter length is there, 2/3 of 2 meter from point A, and 1/3 of 2 by 2/3 from point B. Okay, we will discuss with an example. With an example, look at here, the 10 kilonewton meter is the non-uniform distributed load is shown here. So from point this is 0, and at this point it is maximum. The total span is 6 meter. Okay, now we can convert this non-uniform distributed load in a single point. That, first of all, find out the magnitude. Equation for magnitude is a 1 half into W into L. Okay, so 1 half, W is 10, and value of length L, that is span, is equal to 6. So we will get a magnitude. What about the distance? It is 2/3 of L, or you can say it is 1/3 of L. Okay, from this point it is 1/3, and from this point it is 2/3. Okay, so 2/3 of 6 meter is 2 multiplied by 6, it 12, 12 divided by 3 is 4 meter. So that's why 4 meter from this direction, and 2 remaining 2 meters from this. The total 2 plus 3 is 5 meter, which is shown over here. First one was uniform distributed, and second was uniform variable load. That was the one, By mistakenly I said non-uniform. So it is uniformly distributed. This kind of load is uniformly distributed load, and this kind of form is, we can say, uniform variable load. Uniform variable load. Okay, uniform variable load. Again I repeat, it's a uniform variable load. So when they are combined, you might be quite confused. Now look at here, we are converted the combined uniform distributed load and uniform variable load into two two single point load. Okay, let us consider with this a simple example. This one is a this one is a given example. We know that the value of W is equally distributed, uniformly distributed in this area. Okay, so bottom area is a rectangle and top area is a, sorry, bottom area is a rectangle and top area is a triangle. Okay, so uniform distributed load, which is in triangle shape, and uniform variable load is in a triangle shape. Okay, so we can solve one by one also, or we can solve with a simple example also. Okay, for uniform distributed load, what is the equation? What is the equation? W1 is the uniform load which is distributed over. So the magnitude is equal to W1 into L into L. So we can get a magnitude. To get a magnitude. And what about the distance from where it is located from point A? That is L by 2. That is L by 2. So that is the distance L by 2, which is shown over here. Okay, which is shown over here. This is a magnitude and this one is a direction. Now to find out the value of W, we need to take the difference between W2 and W1 so that we can get the maximum height of uniform variable load from where to where it is getting upgraded. At from this point, from this point, it is considered as a 0, or you can say W1, and at this point it is W2. Okay, so it is varying from this point to this point. So W2 minus W1 will give the exact magnitude of maximum uh, force applied. So when we start with the calculating the magnitude for uniform variable load, that is W2 minus W1, it is the value of magnitude, then multiply by L and divided by 2, the whole divided by 2. So we can easily get the value of the magnitude of a single point. Now location. Location, as we know that from this to this, it should be two-third. It should be two-third of length. Okay. And from here to here, it should be one-third. So what we can do, we can directly find out from point B, that is a one-third of length. That is a one-third of length. So placing of this single point is done. Whenever you have a combination of uniform distributed load and uniform variable load, you can convert these two into two different single point load similarly. Okay, I hope this will understood, you are able to understood very easily. It is not that much complicated to understand. You need to understand first type of load, then how to calculate converted the uniform distributed load into single point of load. Okay, this is simple. Another, you by using different type of supports, you have to identify the reactions. That much you have to remember to solve the problems. Okay, so that much for today. Thank you. Thank you very much.